Okay, so I'm gonna go through a 2021 paper. So let's take. I'm not gonna go through everything. I'm gonna go through the main points that you generally have problems with. So in this case, which two elements react vigorously? So you obviously choose the more of the most reactive metals, potassium, and non-metal, which is in this case chlorine. This is just chlorine. This is a transition metal, which is copper. So even though normally we deal with copper in terms of copper 2, can there be copper 1? Can there be copper 3? Possibly, because of the very fact that it is in the transition metal block. Amphoteric, quite standard, aluminium 288 should be potassium is 2881 potassium, and chlorine is 287 chlorine. So this page is generally quite fine. This page also quite fine, so I'm gonna move on. This one, okay, honestly this question is quite standard. You realize that this comes out very frequently, so it should be something standard, so shouldn't be an issue. This one is an issue. Students don't do so well here, because first and foremost you need to realize that they are both gases. So what if they are both gases? They are both gases and they have relatively similar, not same, but similar boiling point. So if they are both gases and they are both similar boiling point, in this case they will actually more likely come out as in the same fraction. Yep. Next, this is not an issue. Enthalpy change of combustion of octane is more negative. This is a big problem. So the general issue you have is, oh yeah, you mentioned that something about more bond lah, more all this. So it's very vague. So perhaps, okay, I'm gonna use a separate page to elaborate on this. So we have octane versus butane, sure. So octane is C8H18 and your butane is C4H10. So I break down for you lah, so you understand what's happening. So C8H18 is drawn this way, 2468. So a lot of the poorer answers are about more bond, more carbon, which shows that you don't really know what's happening. So the equation is C8H18 plus O2 give you CO2 plus H2O 8, 9, 16, 25 over 2. Okay, don't worry about that fraction. I just want to make it easier to compare. So in exam, they don't need you to actually be able to write everything out, figure how many bonds, but at least you must have a rough idea of what's happening and use a little bit of logic. So I will show you. So 4, 8, 8 plus 13 over 2. So you look at this and what are the main things you can see? The main things you can see, actually a lot of things is changing. First, this segment. Okay, that is one thing that, so it seems like now you need to break more bond. Then you think, break bond means take in energy. Do you actually even need to talk about that? Remember, what you are trying to explain? You're trying to explain why the enthalpy change is more negative. Means give out more energy. This one doesn't tell me give out energy. This one take in. If anything, it is the opposite. So should you say this? Don't need lah. Ignore it. Next one. Hey, I break more oxygen also. Then again, same thing. Oxygen is a reactant. You are breaking it. Breaking it means take in energy. Why would you want to say this in your question? It's not gonna help you prove your answer. So that means that the focus is now on the green and the purple. So green means you are forming more bond. If you can even tell them more C double bond O, very good, fantastic. And you are also forming more OH bond. So this is what you need to tell them. You're forming more OH, a CO bond, and the other ones I'm not going to mention. It's not helping my answer. So I will say that, for octane, more energy is given out or released has more strong. I'll use the word strong too. Stronger bond give out more energy. More strong C double bond O and O single bond H bonds are formed. This will be the basis of my argument per se. Because if you decide to talk about the orange and the red, that doesn't help you explain why give out energy. That would tell you why you have lesser net loss. So it's like, oh, like that one, yes. After that, calculation, not an issue. This is not an issue. Electrolysis is generally not so big a problem. This part. Most of you can tell me that, oh, there are impurities present in the hematite. Definitely makes sense because why? Yes, we often say hematite is Fe2O3, but hematite is the name of the ore. So it is not iron trioxide, it's just hematite. So it is mostly hematite, mostly iron trioxide. Confirm got impurity one, cause all these rocks lah, hematite lah, all they dig from in nature one. Confirm got extra things like sand lah and all the other things. So impurities makes complete sense. Then what could be other things going on? So then that is the part that you might want. So you may not even realize you need to give me 2 reasons. I see 2 marks. I see so many lines. I probably think 2 reasons. Another thing here, reasons. Plural means 2. Okay, so you might be wondering, how come? How come produce less iron? So you need to come up with possible reasons, not just nonsense reasons. So possible reasons is, well, this whole thing is about you have hot air inside. Oh, it's very hot. The oxygen would combust, so on and so forth. Yeah, that's fine. But is it possible that your nitrogen in the air react with the pure iron form? So you have lesser iron form. Possible. Another thing is, so this whole thing is to produce iron, right? But honestly, this iron have a name to it. It's called pig iron. The iron look like a pig? No lah. Pig iron simply means it is very pure, but there is often 4 to 5% carbon present. So the blast furnace is merely the main step to produce iron, but not the 100% efficient. Because honestly, normally when we make iron, we don't stop at iron. Iron is, frankly speaking, not that useful because it's a pure metal. It is soft, ductile, malleable. Usually, we'll make it into steel. Yeah. So these are the possible reasons. Source of gas, not so much of an issue. Generally quite okay. These are all quite okay one. For dot and cross, you look at this dot and cross and you go like, what? 4 different elements? So what you can do is you can use this thing called a legend. Oops. Legend. So I know it's dot and cross. Can you use circle, cross, triangle, star? By all means, go ahead. You just have to tell me what it means. That's why you need to be you need to have a legend. So this is covalent in nature. This is not ionic. If you think of it as ionic, you'll be like, oh, must be the NH2 minus CO or NH2 plus. Like, what are all these? You have never seen this before. So, okay, they tell you NH2CO. So, of course, you have C and O. So, you deal with the C and O lah. Okay, NH2 is N, H. Okay, you might struggle with figuring out how this thing look like. It is okay. If it is that the case, you can try drawing the organic version of the structure formula. Means you just draw like arrow first, C O. Okay, C and O. I recall that O has 6 valence electron. Means O need 2 more. Then okay, then double bond. So this one 6 becomes 8. This one 4 becomes 6. Then NH2 NH2. I know NH2 look like this. N single bond N single bond H. So in this case, your N from 5 valence electron becomes 6, becomes 7. So how can you need to think about it lah. So you have 2 of these NH2. Apparently the N needs 1 electron. Need to bind with the other part. Which so that means the N is lacking. The C is lacking. How do you think they can bond together lah? And since N need 1 electron, you're gonna form a single bond. So it will look like a single bond being formed. Ta-da! So cross dot cross dot cross 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 cross. So cross represents electron of O. Dot represents electron of C. Triangle represents electron of N. And star okay lah, star represents electron of H. Cool. Make sure your symbols looks legit. Okay, this is not very legit. Triangle dot. That's it. That's why it's 3 marks. Okay, next segment. DEF too hot. Not an issue. Benefit to the environment of using DEF. It's okay. This one doesn't solve all problems. You see, the keyword here is environmental. So definitely CO2, greenhouse gas, global warming, so on and so forth. All the usual explanation. Yes, give me that for sure. Yeah. Actually, give one reason. Yeah, that's the main thing. Overall equation. Okay, some of you may struggle with the overall equation. So let's try and do overall equation now. Let me show you how to do it then. Okay, I'm gonna open a new page. So let's take a look. Okay, the whole idea of overall equation. Okay, so in O level, often we are used to one reaction A plus B give me C plus D. Finish. As you now prepare for exam and also gonna progress to JC, you will come to realize that many reactions consist of multiple steps. So that's why you need to know how to combine the different steps together. So let's look at step 1 then. Looking at step 1 as step 1 produces NH3 and CO2. Cool. Did any of the product produced in step 1 react in the next step? Have NH3. Oh. So that means your NH3 will basically be used up. See what equation they want us to write? Let's take a look. The equation says, with NO2. So that means this is an irrelevant equation. So you need to take a look at this and see how to balance. So this is 2NO2, this is 8. Sorry, this is 2NH3, this is 8NH3. So you need to times 4. It's something like your electrolysis half equation. So this becomes 4, 8. 4. The next thing you do is you add all the reactant together. And you add all the product together. Then you can simplify it after that. Eight NH3, 4H2O. And there you have it. Your final answer is 4 urea plus 6 NO2, 4 CO2 plus 7 N2. Cool. That's it. Calculations are okay. Acid. Okay, so the problem with A part 1, right, is not because you don't know, it's because you never read the question. Because why? First and foremost, first question, which one fit, which one do not fit? So you cannot tell me, oh, this one fit, and you automatically assume the other one cannot. Just tell them. You tell them that, okay, you are hydrochloric, sulfuric, okay? So hydrochloric acid and ethanoic acid fits, sulfuric acid not fits. That's it. You explicitly tell them the answer and don't let them guess. And the examiner won't guess one. The answer not clear, you don't get the mark. Simple as that. Make sure the answer is clear. Next thing, explain with reference to the ions. Did they just say cation? They didn't. So why did some of you, or most of you, give me just cation? So you tell them that in HCl, in CH3COH, they both have H plus and Cl minus, CH3CO minus. And all these are basically fit into the A minus mole. Whereas H2SO4 gives you 2H plus and SO4 2 minus. This is HA. This one will end up with H2A. So it does not fit the general formula. Basically, these are the main thing. I need to see the ions present and you prove to them basically. Part 2 and part 3 quite well done. This segment are very important. Really very important. Because it's something that has been tested in a previous year paper in O-level, but it's something that students generally consistently don't get it. Why? Even the answer key also a bit wonky. Okay, a lot of you try to explain using the mathematical model. Honestly, cannot. Because why? In your mind, right, you're very simplistic. What is simplistic? So you do the maths, you write down this. pH equal to K 1 over acid concentration. Yeah, most of you think of it this way. So your K is a one-dimensional thing. Your K is like X. What makes you think so? You mean my K cannot be X squared? It's still a constant, what, isn't it? You mean X squared cannot be constant? Can what? Because the two main things you care about here is pH and acid concentration. So they are not equal. Okay, let me give you another example. Okay, so for example, okay, I'm gonna use a real formula, but maybe that formula is not chemistry. Just to draw across my point. So my point is, so let's say okay, maybe not force. The Ke. K is half mv squared, right? We know that. Wow, maths formula. Physics formula, very cool. So what if I want you to say that K, so I'm gonna say Ke is proportionate to mass. Well, most of you will tell me, yes, Ke is proportional to mass. So in this case, you write down, oh, Ke equal to K, which is a constant, times mass. Really? So in this case, your K is what? Your K is V squared over 2. It's not a linear thing. So my point here is this. Don't look at this for chemistry when they ask you whether it's directly proportionate or indirectly proportionate. You don't go and calculate the constant. That is not the point. Because to you, your constant is linear. Sorry, not yet. Your constant is a first degree. Could your constant be a square? Could be a cube. Can. So the point here is, don't calculate constant when proving whether proportionate directly or indirectly proportionate. That is the main point. This is not what I say one. This is O-level say one. You don't believe, you go ahead. Simple as that. So in this case, all you need to do is to show that it is not consistent. So, and he say use data. So let's find the data that it is not proportionate. So you can simply choose data such as let me take a look. pH is concentration of acid. So I just choose this and this. I'll quote and say, oh, hydrochloric acid. Both hydrochloric acid and ethanol acid has a concentration of 0.1. But yet, the pH of HCl is 1. The pH of ethanol acid is 2.9. We know the reason. We know that it's because it is a strong acidic acid. But honestly, did the question ask? No what? Question just say proof. Proof that it is not correct. Done. Simple as that. Next one. Factors. Please. I cannot say the concentration of acid. Why? Because the right before it, you prove already concentration of acid does not affect pH. And here you tell me it affect pH. Why? It contradicts what is given, isn't it? So what are the factors that we deal with? Concentration of H+. Strong acid versus weak acid. Be very careful. I cannot use the word weaker or stronger acid. Just strong and weak. And you can use your monobasic, dibasic. Careful again, careful. Using information. So it is best that when you explain, you quote the relevant values to support your argument. 3 mark, 3 points. Alright? Yeah. So in this case, you have HCl 0.04. So you have 0.04 because strong acid. This is also strong acid, 0.10. Then you may be wondering, how? So for sulfuric acid, this is very easy. Why? Because you just have H plus 0.1. You screw up. Can you see something that's H plus 0.1? You can, okay? So the answer is 1. So for sulfuric acid, I'm looking out for a very specific number, not even 1. It's 1.0. So that's how it works. For hydrochloric acid, 0.04. Let's take a look. Hey, 0.04 So I'm looking out for 1.4 exactly. So yeah, that's it, 1.4. Okay, this one not an issue. This is molecule, not an issue. It's more careless than anything. Polyester. Okay, this question. Read carefully. They say polyester. So in your mind, polyester is one word, means one thing to explain. Really? Isn't it poly and ester? Really, does it mean that one word is one thing? Can your one word consist of multiple things inside? Cannot. You need to explain why is it poly, many, ester, COOs. Yeah. So one polyester has multiple ester linkage or whatever you call it. Yes, so for part 2, quite simple. And B, not an issue. Not an issue. Yes, for B is not so. You imagine, isn't it just bonding? Doesn't it just means, five, how much? 5 marks, free one. No, you need to be careful. Why? You need to be specific and don't miss out points. First, different properties. So how many properties you have? A lot of properties. You have first, melting boiling point. Second, density. Third, electrical conductivity. So you explain all 3 points. Yeah, and you tell them, and they say it's between them. So it's dense. First, SiO2 vs Al2O3. Al2O3 versus CO. This is simple molecular. This is giant molecular. This is giant ionic lattice. First comparison. Second comparison. Do we need to explain SiO2 and aluminum? Meaning you do need to explain giant molecular versus giant ionic. Don't really need to lah. You can just tell them that this one, a lot of energy, strong electrostatic, forces of attraction between oppositely charged ions. This one, a lot of energy, many strong covalent bonds between atoms in a giant network of atoms. Do you need to compare between these two? I don't think so. They are both very high, and we don't really learn how to compare between these two. Then you can build on it. This one is little energy, weak intermolecular forces of attraction between. You see, I always must say between what? So this one have low melting boiling point, which means it's a gas. And why does gases have low density? Then you can link it to your low density. These two basically end up with high melting boiling point, which ends up with high density. Then conducting electricity is another thing to talk about. So you tell me that CO got no delocalized. Okay, when you explain why something cannot conduct, you need to tell me that it has neither of both things. So there is no delocalized electrons, there is no mobile ions. They got nothing. Your SiO2, same. Whereas for Al2O3, in molten, there's basically no more lattice. So there is mobile ions. So can conduct, cannot conduct. So these 5 marks seem easy, but it's almost like a mini essay question. You need to be careful and tell me each point. This one not an issue, you can just calculate. Yeah. Okay, for this is pretty fine. It's just that your explanation need to be clear and in-depth. Yeah, so you need to be careful and don't just give me very vague answers. This is fine. This is 3 marks. Just need to be careful and explain every single point. More concept, limiting reactant, not issue. So that's about it lah.